Thanks for joining us for the Innovate with AI Azure Bootcamp. My name's Lucas Dumitescu, and I'm one of the AI Global Black Belts here at Microsoft. One of the coolest sounding teams, we actually get to work across the globe with many different customers to build out exciting generative AI experiences. My pronouns are he, him. I'm sitting here in not very sunny Melbourne, Australia. And I was actually asked for people who are vision impaired that are listening to the session to give a description of myself for those listening. And I thought today we're here to talk about the picking the right generative AI model for the job. And I thought, what better way to talk about this than to actually show the model in practice? So what I wanted to show you was, let's jump into Azure AI Studio and let's ask the model to describe me. Can you describe the person in this photo in 2 sentences? So we'll send it off and we'll see what the model thinks I look like.
The person is wearing a light-colored, button-down shirt and is seated in a room with musical instruments, including a bass guitar, 2 electric guitars, a saxophone, and a keyboard.
So you can see that the model can actually not just do text, like what we talk about large language models, but now we're starting to look at foundation models, where models can combine images, audio, and text to actually analyze and respond to people and build out new types of customer experiences. And just on this example, if you haven't seen this video, Be My Eyes, it's just amazing how not just things like object detection that we had before, where you can detect objects in images, we can now talk to images. And even on the example you saw before, I could say, hey, tell me a bit more about the guitar in the background. And you can have this conversation with images powered by generative AI models. So really amazing what some of these models are starting to bring to our customer experiences. So today we're going to be talking about how, with so many models out there, how do I know what's the right one to choose? And today we're going to cover what models are out there. We're going to talk about how to choose between those different models. What are some of the benchmarks? What are the criteria? How should I be thinking about this for my applications? And then we'll be talking about other considerations, things like multimodality, cost, fine-tuning, and so on. And then lastly, we'll be wrapping up by going through what are the resources I have available to me to help me actually go and implement and do these things. Before we jump into it, I'm sure there's a mixture of people listening to this, whether you're from a business background, you're a product owner who's building an AI product, maybe you're a technical developer and you love getting down into the weeds. We'll have a little bit of something for everyone. But what I do want to cover is also just the summary to help ground this conversation, because sometimes it can be really confusing. And the answer, in my opinion, is actually relatively simple. And this is what I see in practice, working day to day, building out generative AI applications. This guidance applies to 95% of scenarios. And that is to start with the most capable, versatile model to deliver business value first. So focus on getting it to work and demonstrating what you're trying to achieve. So generally, most of the time, I would start with something like GPT-4o. We'll talk more about the models later. But starting with the biggest, best language model, develop my application, get it to work, and then only once I've unlocked that business value, I would focus on optimization. How can I bring in a small language model, or maybe a fine-tuned model, or a domain-specific model, or maybe just staying with that large language model? So this is a real common trap I see. There's so many exciting models, there's so many exciting things to explore, but most of the time, you should start with the large language model, get it to work, and then understand more. And I'll actually give you some practical examples of when a small language model kind of runs out of steam, and when you do need a large language model, and examples from my experience building out these applications where I didn't follow this guidance and actually ran into a bit of trouble. So the first question we've got is, what models are out there? There's so many models that we have access to. In Azure AI Studio, and we'll see the model catalog in just a moment, we have one of the widest ranges of models out there. There's the OpenAI models. This is really what kicked it all off. If you remember ChatGPT, GPT 3.5, this really launched this era of generative AI that we find ourselves in today. There's other models as well, like the Mistral family of models, which are really fantastic, the Meta family of models, with models like their Llama model. Microsoft have released the Phi series of small language models, which are really powerful. There's so many different models that are out there. So why don't we take a look first, and let's go have a look at the model catalog. I'll try to make this session really applied. This will be from the lens of an AI practitioner, someone who's hands-on. Where do I go to get the material and the resources that I use in my day-to-day to make decisions when I'm building applications together with clients? So here in the catalog, you can see so many different models. You can filter them and so on. But just to give you a quick start as to how to explore and start to look through them. Here's one example. Let's just click on, the Phi 3 small 8K instructor model. And what you find is there's a model card in here. And the model card will give you information. Just wait for it to refresh. Here we go. So you've got a model summary explaining a bit of information about it, some of the primary and intended use cases for those models, how the model was trained, a bit about the architecture and all this kind of stuff, some of the data sets that we used. We'll talk about the benchmarks a little bit later, so I'll skip over that, and even some information about how to use the model. So much information here to help you get started and explore these different models. But when I talk about a large language model and a small language model, maybe just a few quick questions that you might have if you're less versed in generative AI and all these models. When I talk about the size of a model, generally we're talking about the number of parameters in that model. Now, it's not the best analogy, but you can think of it a little bit as of the size of the brain. The number of neurons that we can tune when we're training the model, the more of them, sometimes the more general and capable and powerful the model becomes. So generally more is better. And that's why when we talk about small language models, you can actually see, I think it talks about in there, or if I go back, you can see when it says 8B, 70B, things like this, that's 8 billion or 70 billion tunable parameters, things that it can keep tweaking as it learns more and more. So when I talk about a small language model, often that would refer to something under about 100 billion. It kind of depends. Large language models, GPT 3.5 was about 175 billion parameters, I believe. And some of the larger ones like GPT-4, it's not actually released, but guesses would be in the hundreds of billions or trillions of parameters. So that's what we mean when we say a large language model and a small language model. And large language models tend to be more expensive. They used to be a little bit slower, but now they're actually getting quite fast. But they tend to have better reasoning capability. So there's a bit of a trade-off between these two. And what we'll explore today is how we can make that design decision as we're building our applications. So let's have a look at a real example of why we would choose one over the other. So here, this is just the Wikipedia page on onboarding, because the later demo we'll talk about onboarding employees into a business, and I'll talk about how you can use larger language models for that. But what we're going to do in AI Studio, we're going to use the chat playground just to give you a real hands-on example of this. So here, I'm going to ask GPT 3.5 Turbo. Originally, I was using this as my smaller language model. This I would have said was medium language model. Right now, just recently announced was GPT-4o Mini, which is actually a new small language model, which is probably going to outperform this model significantly. I've already set up this demo, so we're going to use this one for now. But generally, when I refer to the small language model, it's something like 3.5, something like 5, something like GPT-4o Mini. So I'm going to put all this information in here, and I'll ask it, summarize this in 2 sentences. So I'm going to ask it to GPT 3.5, and it gives us a response. And I'm going to ask it, you can see here, and I might make it a little bit bigger for you. You can see it here where it's doing it for GPT-4 Omni, asking the same question. And what you can see is there's basically minimal difference between these 2 responses. So you can see here for this type of task, for summarization, for classification, for fairly simple reasoning tasks, there's not too much of a difference between these 2 models. And when we talk about costs and all the other bits and pieces, clearly you should choose the cheaper model for something like this. And often what people do in their applications is they will break the logic, and we'll talk about that in a moment, where you break the logic, where you use the large language model for the more complicated big decisions, and then you use the small language model for simpler explanation, summarization, rewriting, these types of tasks. And that can be a great way that you can combine different models to get the best out of both. So here we can see not too much of a difference for a task like this. One consideration you may have too when choosing a model is the context window. So the context window is how many words or tokens you can put into the model before it runs out of space. So it's like how long can the question be? How much background information can you give the model before it runs out of memory space? And you can see that in here. So running through the Azure Microsoft Learn documentation, you can see for each model, it actually says the context window. So in this case, GPT 3.5 Turbo has a context window of 16,000 tokens, whereas something like GPT-4o up here somewhere has about 128,000 tokens as the context window. So the context window, which is how big a document could I have asked that to summarize? You can see with other models, I can ask it to summarize a much bigger amount of text. So another thing to consider. But let's look at a very clear-cut example where you do need a more complex reasoning capability. So in this demo, what we're going to be looking at is, this is called a multi-agent scenario. So this is where we've got many different AI agents. And what you can see here, I'll zoom in a little bit, is you can see our little agents. We call it our business in a box. And in the box, you can see these little agents at their desks. Each of them has a specific knowledge area. So you might have the HR agent who knows a lot about HR processes. You've got the tech support agent who can do things like order a laptop or provision new accounts to users and this kind of stuff. So you've got these AIs that work together collaboratively to solve more complex problems, and they actually are taking action on the real world, which is really, really cool. But of course, this additional reasoning capability requires a larger language model. So what we might do here is we're going to ask the system to onboard a new employee. So they're onboarding me in this case. And what you're going to see them do as they go and chat backwards and forwards, we can sort of see under the hood how they're going about solving this problem. You can see first they ask for a little bit more information. And I can say, so it wants my role, let's just say engineer, I work in IT, and here's my start date. And now what you'll see is the AIs go off and they'll use a bunch of tools. They'll understand, like, what's the process for onboarding people? How do we go about all this kind of stuff? To achieve a complicated use case like this, you need to use a model like GPT-4 Omni, one of the large language models. And the reason for that is, it's very complex to know, hey, I've got all these different, me for the AI is thinking, I've got all these different things I could do. I've got all these other AIs I could talk to. Who should I talk to next? What should the next action be? There's a lot of decisioning that has to happen. And that's why, if anyone's ever, and I'll give you a real example from my own life where I didn't follow that guidance of starting with the best model. I thought, hey, I'll just use 3.5. I was building a planner. So it's where the AI can plan out a number of steps and then execute them using semantic kernel. If you don't know what it is, it doesn't really matter too much. But I was like, oh, I'm just going to use 3.5. It's a little bit quicker. It's a bit cheaper. I'll just do the development with that. And I was getting all sorts of crazy errors. 30% of the time, like sometimes it would work. And I was like, amazing. And then sometimes it would fail, and it would fail in weird, unexpected ways. Because the model I was using, in this case, this was back a bit, I was using 3.5 instead of 4. The model didn't have the reasoning capability to do function calling properly. And it would just have all sorts of strange errors. So similarly with this demo, if I try and run it, and I can probably pull it up, you can see here that this is the demo I showed you before. It's running in prompt flow. It's using something called AutoGen, which is the multi-agent technology that sits under it. And I can actually run it. And here in this demo, I've actually switched it to use GPT 3.5 instead. And as it's running through the demo, the AI start talking to each other. Sometimes they work. Sometimes they have all sorts of weird, wonderful mistakes. Sometimes they get stuck in a loop where they're just saying, they get to the end, they're like, oh, thanks for your help. And then the other AI says, no, thank you for your help. And then the third AI chimes in, it's like, no, no, thank you for your help. And they get stuck in a loop where they just keep thanking each other. This can happen with the larger models, but as well, sometimes they just struggle to perform these tasks. So we saw using multi-agents is a great example of much more complex tasks and things beyond just simple RAG applications that you're going to be wanting to do more and more of. So many different models, many different levels of capability, but I would always bring it back to start with the most powerful model and then optimize later. So now what we're going to do is, we've talked a little bit about the differences in capability and tried to show some practical examples of those two models in action. Let's have a look at what are the criteria we use to actually choose the model. So there's a life cycle process that we can apply to how we actually do this decisioning. And there's two key points where we want to be able to measure the model. Let's first start with understanding some of the public benchmarks. This is probably something you've seen. Probably some of you might use it day to day. Some of you might have no idea what these different benchmarks are. So let's dive first into that, understand what the benchmarks are good for and some of the flaws with the benchmarks, and then understand how can you apply an analysis to which model is best in your own context. So first, let's understand what the benchmarks are. So jumping back into Azure AI Studio, we'll go over here. Let's have a look at the benchmarks. So the benchmarks are essentially a collection of data sets across a wide range of different tasks. And those tasks might range from humanities questions to questions in the legal domain to coding tasks and challenges and so on. So you can see here, all these different colored dots are the different benchmarks, and each model has a different score. And what you can see here on the x-axis, I'll just zoom in a little bit for you. You can see there's all these different models. So you can see the GPT models, you can see Phi, you can see Llama, some of the other ones we talked about. I'm not going to go into specific analysis of the specific scores for the models, but here, what you might want to do is say, hey, my application is, let's go through a couple of them. I'm looking for something that's going to be doing STEM. Let's say it's for education and it's educating school children about, math, science, and all sorts of things. You might look at these blue dots here and go, well, okay, which model should I shortlist to evaluate? And you could say, well, here we can see the GPT-4 models are doing pretty well. You can see Llama's doing quite well as well. There are other models as well that aren't captured on here. So you may want to look at other public benchmarks to have a number of other points to compare to. But you might start here and go, okay, well, this looks like, the relevant performance for what I'm looking for. However, there are some downsides with the benchmarks and their use. And what I might do is I'll just pull up this article, this research article, and show you some examples of what those challenges are. So here, there's a number of, in the data sets, basically it's a collection of questions. And I'll show you here an example. These are some of the questions that form the MMLU, which is one of the most commonly referred to benchmarking data sets. And you can see some of these questions. It's things like, what's the largest ocean on Earth? And other questions like this. And what this article is talking about or this research paper is talking about, there's a number of errors in these benchmarks. And that's why, and the other challenge that we have with the benchmarks is a lot of this data has leaked into the training of the models. So because the models are aware of the questions, it's like cheating on a test, they tend to do pretty well. So the benchmarks are very useful for understanding the sort of overall performance, but they're not perfect, and they're not necessarily, the question you should really be asking is this model the best for my application in my context with my data? So how can we go about answering that? Well, now that we've sort of shortlisted the initial models we think might be good candidates, we might want to do something using manual evaluations. So if we jump over into, sorry, just before we jump into evaluation, the other commonly quoted public reference is to use the LIMSYS leaderboard. So this is a little bit different to the benchmarks. The benchmarks are based on questions. In this case, what we talk about, and you probably commonly hear about this leaderboard, we actually look and we can see a ranking of these models, but where does the ranking come from? The ranking comes from the chatbot arena, where basically we can go in here and anyone, this is open to anyone. So it's a sort of a public collection of everyone's use cases. And let's take this example that we had before, of summarizing this thing, and we'll send this to the chatbot arena. And what we'll see here is two different models, and the two different models give us a response. And if we look at the response, we might want to determine, which of these is better? Was model A or model B better? And looking at this response, honestly, both of them are pretty similar. We might say it's a tie and then submit that to the leaderboards. And then you can see at the end, it says, hey, this is actually a new model that I think just came out, Llama 3.1. And this one over here is Gemini. So this information, this kind of contribution goes into the score and sets the ranking of this LIMSYS leaderboard. So this is often a useful way of going beyond the benchmarks. In terms of what people's opinion is as to how useful a model is, you can refer to this leaderboard. But as I mentioned, these again are in the general context, how useful is something. So let's look at how we can evaluate it in our context. So in here, this is the Azure AI Studio evaluation tool. And in here, we're using manual evaluations. So what it lets us do is we have a data set. And in my application, the model is giving information about Azure OpenAI models from the Azure OpenAI service. So what we're doing here is we've got an input, and this is a data set like a CSV or an Excel file, or wherever else you might source some data from, of collections of an input. So what's the question users might ask? And what's the expected response? So in this case, does Azure OpenAI use customer data to retrain models? No, Azure OpenAI doesn't use data to retrain models. And what you can see is when I run this, if I'm just using an off-the-shelf model, in this case, it does know the answer to this one. Let's have a look at another response down here. You can see when I ask this other question, can I find GPT-4 Turbo Preview in Azure OpenAI? Because this is just the default model, it says, as of my last update, this is available. However, you need to go check X, Y, and Z because it doesn't have access to enterprise data. So in this case, we might say, this wasn't the most helpful response, and we give it a thumbs down. And what you do is you get teams of human evaluators to go through and evaluate whether or not the model is performing well. And you might compare the responses of one model versus another. And at the end, you get a score and you say, this one was good, this one was bad, and you make a decision as a team. Just to illustrate as well that challenge we had where the model didn't really know much about the up-to-date information with the models, I can actually ground the model in my own organization's data. In this case, I'm just using the Microsoft Learn documentation. And now if I rerun that question, I think it was this one here, we should see the response come back using information that I've provided to it. So this is called retrieval augmented generation. So we'll give that a moment to come back. So you can see, yes, you can find this. Here's some citations with information, and it's much more confident in its response because it knows that information is up to date. So we would give this one a thumbs up. You might think though, well, some of the challenges with this process is it's fairly human intensive. A human expert needs to sit down and evaluate all of the data set. Maybe you've got 100 questions, maybe you've got 1,000 questions. It takes a lot of time. And the other challenge you have is as you are continuously evaluating and iterating throughout the development of your application, each time you want to assess the performance, you need to run it through with your team of human SMEs. So in general, just to zoom out for a moment, that some of the challenges that you have when you're building these applications at scale is the challenge when you're developing. How do we know as we develop whether we're improving the application and it's getting better? And the other challenge you have is when you operationalize it. So how do we know that as new model updates come out, as we change our prompts, as the data in our vector database changes over time as we add more information, is our application getting better or is it getting worse? We don't want to just evaluate it when we launch and then never evaluate it again. So this is a very common challenge and one I work with different organizations to solve and work through. And the way we solve it is generally using automated evaluations. So this is very similar to the world of, DevOps, CI/CD, ML ops, and now what we call LLM ops. And the key thing to be able to do it is to have an evaluation framework that lets you do this analysis. So let's go through and have a look at what it means to operationalize. So jumping back into the studio, we've seen the manual evaluations. Let's take a look at automated evaluations. In an automated evaluation, I'll show you the process. In here, we go and we create this. We've already got a data set. There's actually a separate workshop I run, which is an hour in itself, just talking about what these metrics are, how we build these data sets, probably beyond the scope of what we're going to talk about today. But I've already got a data set which basically has things like, what's the question? What was the model's answer? What was the ground truth as labeled by a human subject matter expert? What was the retrieved documents and what documents should have been retrieved in order to answer that question, and so on and so forth. Again, beyond the scope of this talk, but just for context and important to understand. In AI Studio, we have these number of different metrics that are provided to you. Many of them are open source and you can actually go and have a look at how they work. They're actually prompts in and of themselves using a large language model. But what they let you do is more important. And what they let you do is evaluate how well your model, and not just your model, how well your application is performing as a whole. Because remember, whilst we're talking about what the right model is for the job, this really needs to be considered in context of the application. If you're just testing the model, the retrieval system is just as important. And often when I work with customers, the reason it's not working isn't because, this model is 2% better on the MMLU versus this model, and if we switch the model, the whole application is going to work better. A lot of the time, to be honest, the model, many of them are very capable, and it's actually the retrieval system or the entire application as a whole. There's a failure somewhere else in the system. So if you're getting the wrong information, of course, the model is going to give you the wrong answer. So using these types of evaluation frameworks, you're not just testing the model, you might be testing the entire system, which is really important. So some of these metrics, you can see here, groundedness. This is an example of, if you've heard of hallucinations. So groundedness helps you measure whether the model is answering using only the information you've given it. GPT similarity is a really great metric for basically correctness, like how accurate or correct is the response of the model, and so on and so forth. And you can actually customize these, make them bespoke to your application. You can add to them and do all sorts of things. But once you run it, again, it's not too important what those metrics are, just that you understand that this is the process by which we evaluate the models. You can see in here, you end up with something like this, and you get a score across your application, how well it's performing. You can even compare two different runs against each other to see, hey, we made one run using, there's a compare button. We did one run using GPT 3.5, and we did one run using GPT-4 Omni. Hey, look how much better, that wasn't the case in this is just a demonstrated, but hey, look how much better this is performing when we made those changes. Or you might go off and do some prompt engineering, and you think you've got some great new idea, and you do it, and then you find, oh man, that really, caused the model to hallucinate. Let's roll back those changes and try a different strategy. So being able to evaluate the models side by side when you swap them as part of an application, really, really powerful. And this really helps you answer the question of, in your context, how does the model perform? And that's the best type of testing you can do. So we've talked a little bit about how you can evaluate across those different criteria of the model, but there's a wide range of other considerations we need to take into account. So one is around multimodality. We saw a little bit at the start where I was using the model to describe what I'm wearing and what I look like and so on. And that was an example of multimodality. This is why we sometimes talk about foundation models rather than large language models, because we're talking about images and speech and so on. And one thing you might have noticed from that demo at the start was a bit of a delay between when I asked the question and when the response came back. And this is something really important to how we build a customer experience. For example, when you talk to smart assistants, you're probably familiar with, you say, hey, and then it listens, and then you say your request, it thinks about it, then it responds. And that's a bit of what you saw there. The model we were using there was a speech to text model. Then it was going through a large language model, GPT-4, and then it was coming back with a text to speech model to actually talk back to me. And this process where we chain many models together can be a little bit slow. So one of the, I think, most exciting developments recently is with GPT-4 Omni. Omni alluding to the ability to work across many different things. And this is one model that can actually bring in all these different modes or modalities into a single model. And it lets you do some pretty incredible things. So I'm going to share a video that Seth shared, a demo at Build this year. And I'll run the demo, and then I'll just call out some key things I hope you catch throughout the video.
All right, let me ask the agent here.
Hey, Seth, how's it going? What can I help you with today?
I am fantastic. I'm sorry, I'm in such a hurry. I'm going to go on an overnight camping hike where we're camping all this. It's going to be dark, cold. Should I use these shoes? It's the mountains. It's probably going to be cold.
Hey, no worries. Let me take a look. Ah, those are the Trek Star hiking sandals. While they're fantastic for summer hikes and keeping your feet cool, they might not be the best choice for cold.
Oh my goodness. So, okay, I'm sorry to interrupt you. Pick the best thing that I should use, and can you just add it to my cart? Just one product.
No worries. Let's go with the Trek Ready hiking boots. They're durable, provide great ankle support, and most importantly, they'll keep your feet warm in the cold mountains. I'll add them to your cart now.
Oh,
ready for checkout?
I see that. Amazing. Muchísimas gracias. Espero que me vaya bien en el campamento.
De nada, Seth. Disfruta de tu campamento y mantente caliente con esas botas. Buena suerte y diviértate en las montañas.
So, what an amazing demo. But some really interesting things that we should call out. One, you could see that he was able to interrupt the model mid-speech and keep talking to it, steering it in a completely new direction. Because this model has speech built into it, it's constantly listening and streaming that audio. So unlike what I showed you at the start, it can actually, it doesn't have to do it in this multi-step process. So when you think about what are those customer experiences we're going to be able to create using these new generation models, it's really amazing. That e-commerce example is a great one. You could see how he was holding up the thing to the camera using the vision component, and even some things like being able to be multilingual and speak in other languages. So these are some of the key advancements, and multimodality is something that you should really consider when you choose a model. There are small language models like Phi can do with vision as well. But think about multimodality. Does my use case need it? And what's the best model to pick for that? Another consideration is fine tuning. And this is something that I think is worth spending a little bit of time diving into. So a challenge, I'm a data scientist at heart. I love training and tweaking with different models. And I'm sure many people watching this session also love doing that. The challenge with it is we come from and this is one of the terms I love the most, traditional machine learning, those that have worked in traditional machine learning, which is anything before 2022 and the generative AI era. We're so used to this process of collecting data, training or fine-tuning a pre-trained model, and then deploying the model. This is kind of the standard bread and butter. With generative AI, it's really a different world where it's more like software engineering, where we're just integrating with applications through we're integrating with APIs and building applications. And the fine-tuning is amazing, and there is a role for it to play, but I do just want to challenge. I'll show very briefly in Azure AI Studio, there's actually some exciting capability for doing fine-tuning. So you can go into here, you can pick a model and go off and start going through the fine-tuning process. And there's even examples, we saw before in the model catalog over here. I'll pull it up. In the model catalog, we saw, I believe it was in here, there was a notebook that actually gives us a walkthrough on how to go and do the fine-tuning. So it's not to say fine-tuning is extremely hard or costly even. Like, the cost is actually not that significant. But what are the real costs associated with fine-tuning, and when should you do it? The real cost comes from the time and effort to curate a good data set, and the challenge that the models evolve and change quite quickly. So there's a number of scenarios where we do and don't do it. And the general guidance goes a little bit like this. What we look at is, first we look at, can we solve the problem through prompt engineering? Prompt engineering, I'm sure you probably heard articles a year ago where everyone's going to be a prompt engineer. This will be the new class of jobs. Basically, prompt engineering has just become part of our day-to-day roles. And prompt engineering is an extremely powerful technique, but it's not the be-all and end-all. For example, in an application I worked on with a customer, just by adding 2 sentences to their application, we were able to make the application run twice as fast. It was actually, there was a team of us that worked together on this, and we actually put together some of these guidance, this guidance in this latency guidebook, which summarizes the work that this team put together, and that example is included in there. So if you're looking at, hey, I need a small language model because latency is really important to my use case, but you're finding that the reasoning capability isn't up to scratch, think about prompt engineering before you just change model. Similarly, we talked about organizations going, hey, I've got all this amazing data. That's our differentiation, is this data we have access to that is unique to us. We might want to fine-tune the model. In practice, most of the time, just through using retrieval augmented generation, which is a pattern. If you haven't heard of it, there's lots of great videos about it. RAG, if you've heard the term. This is the main way that we bring data into our applications. The reason we do it is because it's cheap, quick, doesn't require any training of the model, and it can solve, between prompt engineering and RAG, we can often solve, 90%, maybe 95% of the problems that I generally see out in the world. So really, only when you've exhausted those options, you should look at fine-tuning. And fine-tuning, if we look across Asia and then we look across the world, it does depend. Like, I'm based out of Australia, and not that many customers are looking to fine-tune. And the reason for that is many of the models are trained in English across even specialized domains like legal domain or medical. There's heaps of data on the internet that pertains to those domains. So the models perform quite well out of the box, and each iteration of a new model tends to perform really well. But I've got colleagues that are part of my team that work out of India or out of Japan. And there, like in India, there's many, many different languages. And even before GPT-4 Omni, some of the languages did not perform that well. Like, for example, the tokenizer, we'll talk a little bit more in a moment, but the tokenizer actually has some challenges when it comes to tokenizing certain characters. So that's not so good. How could we fine-tune a model to be better at that task? Or if you have a very specific scenario, like very specific coding standards within your organization that only you follow, or some kind of proprietary software that you need the model to understand, that would be a good example of where you might apply fine-tuning. So fine-tuning is really powerful. It doesn't take that long, but it does take a lot of effort to manage and lifecycle compared to prompt engineering and retrieval augmented generation. So definitely start there before you go to fine-tuning. And of course, at the very bottom of the pyramid for the eagle-eyed is training a new model. Generally, only very large enterprises do this because the cost involved with training a foundation model from scratch is very high. But it is something we can do. And if it's something you're interested in, you can always reach out to your account team. So fine tuning, really exciting, but tend to keep it in your back pocket going forward. Now, probably the biggest consideration is cost. And we're going to actually look at some of the costs and talk about when and how to trade off these different costs and how to analyze them. So if we have a look, let's start first with the Azure OpenAI pricing page. So here you can see we've got all the different models, and you can scroll down, there's heaps of other ones too. And we can see here that we have a price. It's per 1,000 tokens. The price has been coming down so much that now we're starting to price it per million tokens, because then you end up with too many zeros coming off the end of the number. But you can see here, for example, GPT-4o, it's at the time of recording, it's $0.005 dollars per 1,000 tokens. So you might be wondering, well, what is a token? Just as an example, this is just an online calculator. You do have to check which model it's doing the tokenization for. But if I say something like, hi, how's it going? You can see that roughly, this isn't always true, but roughly each word is a token. That's not always the case. But what you want to do is count how many tokens you've got, and then you multiply it by this price. So that's how I go about assessing use cases. And what you might want to consider is, okay, so this is for the large language models that we're talking about here. We've just recently announced GPT-4 Mini, which is one of the small language models. And if we go through here, we can see here that we've got 15 cents per million input tokens, pardon me, and 60 cents per million output tokens. So you can see that if you do the numbers and convert it, when you compare it to the large language model, that's a difference of something like, 30 times in the price difference between the two. So it's a large difference between the large language model and the small language models. And just as another example, here you can see the Phi small language model series, and you can see the pricing here. This one has 3 zeros. It's a little bit hard to see because there's so many decimal points. But you can see the difference between the models is fairly substantial between a large language model and a small language model. So you do need to consider the cost. Now, the thing is, and this is often what we see too in practice, cost is not everything. What you should be looking at is, what is the value of this application and what is the business value that's being driven by it? So just as an example, you might have a model that's classifying certain outcomes, and each of those decisions might be worth thousands of dollars. And say the small language model has an accuracy of 95% and the large language model has an accuracy of 98%. In this case, you might be willing to spend significantly more in order to get that extra few percent of accuracy, because the decision and the rectification of errors is so expensive or time consuming. So it's really important to consider, what is the value my application is delivering, rather than just looking at the cost in isolation. Of course, if you're just tinkering, you're building a little chatbot that people can talk to, it's unauthenticated, anyone on the internet can hit it, perhaps you're more likely to use a small language model to keep the cost down. And as we talked about right at the start, often you chain the decisioning of these models. So you start with the large language model, you use it to make the complex decisions, and then you can use the small language model for some of the simpler steps to reduce cost. So cost is only one part of the decision-making process. And again, I would encourage you to always start with the biggest model, because during the development process, the costs are relatively insignificant. Of course, once you go to production, you can then say, well, how we can test other models using those evaluation frameworks and strategies we talked about before to see, how low can you go before you start impacting application performance. And if you're getting value at the end of the day, the cost tends to, and you do need to consider it, tends not to be as significant as the value you can extract from the system. So cost, really important, tends to be a fairly big gap. Originally, unfortunately, the models move so fast. Before, the gap between the large models and the small models, for example, between GPT-4 Omni and GPT 3.5 was actually getting pretty close. It was only maybe like 4 or 5 times the difference in price. And now with GPT-4 Omni, the cost has come down so significantly that, again, there's a fairly big gap between the two. So definitely a very important consideration, but always think about value. And just the last point, because this often comes up when I work with customers and talk about cost. I was working with one customer and we were talking about what are some strategies to reduce ongoing cost of the model. And we were looking at, hey, could we fine tune the model? Could we do some like LLM Lingua, which is like a prompt compression technique to reduce that? In that article I showed, there's some really cool techniques about using output coding where you can sort of like have a code for classifying things to reduce output tokens. And we talked about all these strategies. My guidance was, if you look at the gap between March and November, we were talking about 3.5, but it's a similar story with 4. The model came down by 6 times in cost. So by doing nothing, by changing nothing about your business case, the cost has come down by 6 times. So you could invest 6 months of effort doing this optimization, trying all the different models, putting all this effort into it, or you could get to production quicker and realize these cost savings by doing nothing. And then you can see again, through to May, it's now a 1/12 of the cost that it used to be. So we continue to see this sort of downward trend in the cost of the models, which is why, of course, you need a business case when you launch an application, but don't get too hung up on cost. Focus on value and the quality of the outcome, and then focus on optimization. And just the last piece on these other considerations to leave you in mind with is, at Build, they also talked about this trajectory that we see with the models. We tend to get a little bit myopic when we're picking models. We look at the benchmarks, we look at the analysis, and we draw a line in the sand and we say, this is where it is right now, this is where the costs are right now, this is where the performance is right now, and this is our view of the world. But the trajectory, if you look back where we started not that long ago, through to GPT-4, through to GPT-4 Omni, and we look ahead at what those next models are likely to be, it's totally different. This is a totally different world that we'll be in 12 months' time. So if you're just starting with building out a chatbot, you're starting to build retrieval augmented generation systems, some of the new models allow us to build these agentic systems like that demo I showed you. This is only the start of what's going to be possible. So you need to keep constantly evaluating, using the latest and greatest, and preparing for what these new, even next generation models are going to unlock. So don't get too stuck on what's here today. Use the best ones, then continue to focus on optimizing going forward. So if you're wondering, well, this is great, what are the tools to help me realize this and make it real, to build my application or my idea that I've been working on? Well, in Azure AI, Azure has a whole range of different platform capabilities to let you do this. So for example, we talked about the model catalog, access to all those different models, different ways to deploy them, either serverless, some of them are available as serverless functions, pay-as-you-go tokens, or some you can deploy. We talked about Azure OpenAI and all the different great GPT models that you've got access to. Azure AI Search is just fantastic if you need a vector database. There's many out there, but some of the functionality it has for real enterprise retrieval augmented generation, beyond just vector lookup, hybrid search, semantic re-ranking, and a myriad of other additional features, actually really, really important for it. We talked about getting the retrieval system right, not just getting the model right. The model's only one little piece of the broader puzzle. Responsible AI, safeguards, Azure AI content safety, the ability to monitor the content coming in and out of your application and make sure it's safe and in line with your company's values. And all the tooling to help you actually operationalize these models. We talked about some of the evaluation pieces, as well as things like prompt flow available in Azure AI Studio. So Microsoft is providing that complete cloud experience, which lets you implement Gen AI at scale. Again, this session is about choosing the right Gen AI model for the job, but the model is only 20% of the effort, and much of the what stops you getting to production and to scale is really having the tooling around the model to help you scale up and succeed. So next steps would be, if you have a managed account, reaching out to your Microsoft representative or account team. I'd really encourage you to explore the Azure AI model catalog. Give it a try. Get hands-on with some of those different models. See how they perform, because it's only really when you touch and feel them that you understand what those differences are. And Also, leverage the Azure Innovate offer. If you've been considering the deployment approaches, if you've been looking at things like provision throughput units to help your application, when you've chosen that model, get the best performance and latency and customer experience, there's a range of offers there to help you scale. Well, that's all we've got time for today. If you've enjoyed today's session and my presentation, it'd mean a lot if you can leave some feedback. There's a link in the chat right now for you to do that. Otherwise, thank you for your time today, and I look forward to seeing what you build.
We hope you enjoyed this digital event. We have specialists on standby to answer your questions for a short while. To ask a question, type it into the chat window now and we'll get to it as quickly as we can.